Alright, here's your guys' homework on coterminal angles and reference angles continued. So it's a mixture of both using degrees and radians, okay? So, example, so find reference angle, number 1. So remember, a reference angle is the angle formed by the terminal side, or by the x-axis and the terminal side, and it's the smaller angle. So, you have to find this one right there. So, I'll make this smaller. What you gotta do is, well, this amount is 180 degrees. So then, if the whole thing was negative 230 degrees, then how much is this amount? And that amount would just be 50. So this one is 50 degrees. Now number 2, that amount is negative 25 pi over 18. So what we have to do is, okay, well, we know that the reference angle is going to be right here because that's the angle formed from the x-axis and the terminal side. Now, in order to find that amount, well, you all know that this is 180 degrees, right? But we know in radians that's the same thing as pi. So if that's pi, then we have to figure out how much this little piece is right there. Well, in order to do that, we should just do 25 pi over 18 minus pi. So 25 pi over 18. And we are not using negative because we know that all reference angles are positive. So 25 pi over 18 minus pi. And now we have to get the same common denominator. So let's put this over 1. Let's multiply top and bottom by 18. So then we get 25 pi minus 18 pi, and both of them are over 18. So common denominator is 18. 25 pi minus 18 pi is 7 pi. So that reference angle right here is going to be 7 pi over 18. Number 3, find the reference angle. So here's the terminal side. Here's the x-axis. So that means that's going to be theta. So let's take a look. Well, that red line, or that red swirl, is negative 7 pi over 9. We know that the whole thing is 180 degrees, or in terms of radians, we know the whole thing is pi, because that's 180 degrees. So if we subtract pi from this, or if we subtract this from pi, then we can find what this angle would give us. So pi minus 7 pi over 9, put this over 1, let's find a common denominator, multiply top and bottom by 9. So then we get 9 pi all over 9. And then rewrite this, minus 7 pi over 9, so now we can subtract. 9 pi minus 7 pi is 2 pi. Keep the common denominator, which is 9. So that reference angle is going to be 2 pi over 9. Number 4. Alright, so that's negative 29 pi over 18. So we know that a whole entire circle is 360 degrees. Or in terms of radians, we know it's 2 pi. So if we know the whole circle is 2 pi, then all we need to do is subtract this from 2 pi in order to give us this angle, which would be our theta. So we get 2 pi minus 29 pi over 18. Put this over 1. Common denominator, multiply top and bottom by 18. So we're going to get 36 pi over 18 minus 29 pi over 18. So 36 pi minus 29 pi is 7 pi. And that's not good, but we're going to get some... There you go. 7 pi all over 18. So that's going to be what our reference angle is. Number 5. Okay, so I'm noticing that this goes a whole circle and then some. So for this problem, it's more of a challenge, but you should eliminate this by getting rid of 360 degrees, because does everyone see that a whole 360 is happening and then there's this amount? So what we want to do is, well, we want to calculate what this angle is, but first let's get rid of 360 because it goes the whole rotation anyways, right? So 31 pi over 9, we're going to subtract a whole 2 pi. So put this over 1, get a common denominator of 9. So you get 31 pi over 9 minus 18 pi over 9. So 31 pi minus 18 pi is 12 pi over 9. Oh no, 13 pi over 9. Okay, so we know, I'll highlight it, we know that this amount right there is 13 pi over 9. So we still have to find the reference angle, right? So the reference angle is this angle, or this x-axis with this terminal side. So we are trying to find that angle measurement right there. Well, we know that's 13 pi over 9, the whole thing. So we know this amount is pi, so that means this amount, the leftover, would be 13 pi over 9 subtracted by pi. So we are going to get minus pi, put this over 1, and find a common denominator. Multiply top and bottom by 9. And we get 13 pi over 9 minus 9 pi over 9, and we get 4 pi over 9. So that theta is going to be 4 pi over 9, which makes sense because, right, 4 pi over 9 plus a whole pi is going to equal to 13 pi over 9, which was this whole thing right there. Alright, number 6. Now, I'm already noticing that there's a whole circle within 640 degrees, so I'm going to subtract 360 from 640, and we're going to get 280 degrees. So we know that after this whole complete circle right there, we know this amount is 280 degrees. So if that's 280 degrees, then to find your reference angle, right, it's the x-axis with the terminal side. So that's that angle. You got to find that angle measurement. So if this is theta, so if that's green and highlight is 280, then we have to find what this amount is. And the only way we could find that is, well, 280 degrees plus this will equal 360. So we're going to do 360 and subtract 280 from it, and it's going to be 80. So this angle measurement is 80 degrees. Okay, number 7. Alright, negative 510 degrees. So negative 510 degrees is a whole entire 360, and then negative 150, which is like right there. So we have to find that. Now, since it's negative 510, we can add by a whole circle, right? Because a whole circle is within that. So negative 510 plus 360, that's going to be negative, or, well, we'll do 510 minus 360, but we know it's going to be negative, which is going to be 150. So we know we're dealing with this little sliver, and that's negative 150 degrees. Now we have to find a reference angle of that. So if you guys notice, here's the terminal side, here's the x-axis, so that means our theta that we're trying to find is right here. So if that's negative 150, then how do we calculate that theta? Well, you know a whole entire half circle is 180 degrees. So to find that angle, we should just do 180 minus 150, and we get 30 degrees. So that reference angle is 30 degrees. Okay, number 8. So for number 8, now 19 pi over 18. Now if some of you guys can't explicitly see what 19 pi over 18 is, you can change this into radians. So, or sorry, we can change it into degrees. So to change it to degrees, we can multiply top and bottom by 180 over pi. The pi's will cancel, the 18 cancels off with a 180 by 10. So that means, you guys, that's going to be negative 190 degrees. So when we draw our sketch, negative 190 degrees is like that much. And if we were to find a reference angle, remember it's the x-axis with the terminal side, the angle measurement of that. So it's that one right there. So we just have to calculate that theta. So that theta would be negative 190, that's the whole thing, but we only want this little piece right there. So we know that this is 180 degrees, right? So if we do 190 minus 180, then this angle measurement would be left over. So 190 minus 180, 10 degrees. So that theta is 10 degrees, but since this already was in radians, we need to make it in radians. So 10 degrees, let's convert it back to radians. So this, now if we put this over 1, this 10 cancels off with that 18 by making this by 180, so it cancels into 18. So pi over 18 will be our reference angle radians. So in 8, as you guys can see, you can convert the radians to degrees, work with degrees, and then your final product, just change it back into radians. Okay, 9. So I'll change this, I'm going to change this to be in degrees. So 180 over pi. Cancel. 12 goes into 18 15 times. So 13 times 15, that's going to be 195. So we're going to get negative 195 degrees. So if you drew a sketch, negative 195 is like right around there. So that's negative 195 degrees, which means your theta is the angle measurement formed from the terminal side and the x-axis, so it's here. So in order to find that theta, right, we know that the whole thing's 195 and this amount is 180, right? So we just need to do 195 minus 180. So we know theta is going to be 15 degrees, but since we started in radians, we need to convert this to radians. So 15 degrees, and converting it to radians, pi over 180. 15 cancels off with the 18, so that's just 12. So it's just going to be pi over 12 radians. Negative 250 degrees, so negative 250 is over here. So we need to find the reference angle. So the reference angle, right, it's the x-axis with the terminal side, angle measurement. So here's the theta. So if that whole thing's negative 250, we know that this whole thing right there is 180. So to find that theta, it's just 250 minus the 180. So 250 minus 180, 70 degrees. So 70 degrees is the reference angle. Alright, so number 11. Now it says state if the given angles are coterminal. So you know they're coterminal if you can subtract or add by 360 or by 2 pi or subtract by 2 pi. So basically, in order for me to determine if 185 and negative 545 degrees are coterminal, I just need to add or subtract to see if it gets me to that point. So 185 minus 360, because that is the direction on, remember, if I keep on subtracting by 360 to 185, then we should get to negative 545 if they are in fact coterminal. So that's negative 175, not negative 545, so I should subtract by 360 even more. And we get negative 535. Now I kept on subtracting by 360, but notice we got very close to negative 545, but we did not get negative 545. So that means these are not coterminal. Alright, 12. So these are in radians. So in order to do this by radians, we should just be adding by, well, starting from here. So if we have 17 pi over 36, in order to get to 161, potentially we just have to be keeping adding by 2 pi. So basically 2 pi for this, right? We know 2 pi, and if we want to make it into having a common denominator of 36, we need to multiply top and bottom by 36. So that would be 72 pi over 36. So if we keep on adding by 72 pi over 36, that's by adding by 2 pi. So 72 pi over 36, we add that. We get 89 pi over 36. Still not 161, so let's see if we add by another 72 pi over 36, since that's the same thing as adding by 2 pi. And we get 161. Well, this is not good. I wonder if it's because it's raining. Alright, let's see if this works. Okay, so I am working out. Gotta love technology, right? So let's get this into turned off my iPad, turning it back on to see if that helps me. Oh, not good, not good. But we're still gonna give it a shot. Oh.